Hello everyone and welcome back to Python lessons on Codecademy. So today we will be continuing on with bitwise operators. More specifically, we'll be looking at bit masks. So a bit mask is just a variable that aids you with bitwise operations. It's just another binary variable or value. A bit mask can help you turn specific bits on, turn others off, or just collect data from the integer about which bits are on or off. In the example above, we want to see if the third bit from the right is on. So if that bit is on, which it is, but you might not know in a program if in the current case it is. So first we create a variable num containing the number 12 or 1100. Next we create a mask with the third bit on. Then we use a bitwise AND operation to see if the third bit from the right of num is on. So desired equals num and mask. So which means because we're using AND, it's going to compare those two numbers, and wherever the ones meet, it's going to return into desired. And then because we don't really need the value of the mask, because that's all it's going to return, we just see if mask is bigger than 0. So if mask is bigger than 0, it means that the bit was on. So then the third bit of num must have been 1 or on, as I want to call it because I'm used to capacitors as well. So what we need to do is define a function check bit 4 with one argument input as an integer. I don't know why they're using input, that's kind of confusing me, but okay. Why it's confusing me is because it's some kind of special variable in Python. I don't know what it actually does. It should check to see if the fourth bit from the right is on. If the bit is on, return on, not print. And if the bits off, then return off. So we can basically just copy this and just remove a few things such as num, and we can make mask 10 and desired num if that and that, then we need to return on. Was it a capital on? Oh, I don't think it was. Or else return off. Not puff, but off. There we go. Save and submit, and it works. So let's actually explain what it does. So we have an input, say it's 1100 again for the sake of the example. So 1100. I'm just going to type it in. You shouldn't do this though. And then we say mask. So actually input equals that. Mask equals that, so we make our fixed variable, and that's the fourth bit from the right. Desired equals input and mask, so it compares the columns of that and the columns of that. And wherever they're the same, it stores it into desired, so it makes a new variable. But if they're off in both places, then you get desired is 0, so therefore it's going to be 0 and it's going to return off. And then because in this case that's true, desired is bigger than 0 because 1 and 1 meet there, it's going to return on. So I'll actually just do that and let's move on. Turn it on. You can also use masks to turn a bit in a number on using OR. You might have a question how to get the OR symbol. It's just the shift and the key, the backward slash key. It's the key above your enter, your right enter. No, your left enter, not the one on the number pad. For example, let's say I want to make sure the rightmost bit of a number A is turned on. I could do this. So using the bitwise operator OR will turn a corresponding bit on if it is off and leave it on if it was already on. So in the editor's variable a, use a bit mask and the value a in order to achieve a result where the third bit from the right of a is turned on. Be sure to print your answer as a binary string. So let's do that, binary string, and what we need to do is pretty much just copy that. But we need to check if something else. So what we'll use in order to achieve the result where the third bit from the right. So we do that. And a is different. And then we need to print binary of desired. That should work, and yes, it does. So let's explain what it does. So mask equals binary of 100 is the same as mask equals binary of 1 2 3 4 5 zeros and 1 2 zeros, because you can add zeros before a number and you still have the same number. So you have this number and this number, so you're comparing the columns of them, and they would come under each other like that. So you get 1 and or 1 is 1, and that gets stored in the desire. So and then you have 1 or 1 is again 1, 0 or 1 is 1, so you turn another bit on, and then everything else we want to stay the same. But if this was already a 1, it's going to stay as 1 because we're not using an XOR. But in this case it's not, so yeah. So let's just move on. Just flip out. Using the XOR operator is very useful for flipping bits. Using XOR on a bit with the number 1 will return a result where that bit is flipped. So for example, let's say I want to flip all of the bits in A. I might do this. So that and that and that. So let's actually do this for ourselves then. In the editor is the 8-bit variable a. Use a bit mask and the value a in order to achieve a result where all of the bits in a are flipped. Be sure to print your answer as binary string. So we make our mask equals 0b 1 2 3 4 5 6 7 8 because we want to flip all of them. And if you wanted to flip a specific one, then you just put a 1 in the position where you want to flip. But in our case we want to actually flip all of them, so we put 1s in all of the positions. And then we make our variable called desired and a XOR mask. And then we want to print whatever desired is, which is binary of desired. So let's see if that works. Yes, it does. So what this does is, so let's align those. We have 0 XOR 1, so it returns 1. Wait, does it? Oh yes, it does. Yes. So it flips it. Then we have 1 XOR 1 and returns the opposite. So it returns the opposite all of those. So we get 1 on the places where there are 1s, on the places where there are 0s, and 0s on the places where there are 1s. So we get that binary number. So let's move on. If you have any questions, please do ask in the comments. I will do my best to explain them as soon as I can, of course. Finally, you can also use the left shift and right shift operators to slide masks into place. Let's say that I want to turn on the 10th bit from the right of the integer a. Instead of writing out the entire number, we slide a bit over using the left bit shift operator. We use 9 because we only need to slide the mask 9 places over from the first bit to reach the 10th bit. Define a function called flipBit. Which reminds me, if you want to learn binary numbers and how to add them, there's one game called Flippy Bit. Just Google it. It should be one of the first few results. It's not mine. I just found it, or I was actually told it at school. But it's quite good to learn it. It's quite a good place to learn it from. It's nothing like Flappy Bird, by the way. but it is pretty annoying. Just going to say that. So okay, let's continue on with this lesson. We need to define a function that takes in two arguments, number and n. Flip the nth bit with the ones bit being the first bit and store it in result. Return the result of calling bin result. So we can do that, bin result, and then we make a variable which is result. Oops, no, what am I doing? What have I done? Result. Okay, so result should equal something which we don't know yet, and now we need to use this in our advantage. So we have a, which is our number, so we need to make a mask which is going to be the binary 1 left shift by n minus 1. We do minus 1 because if we just do n, then it's going to do left shift bit left shift 11 times instead of what we actually wanted, which is 10 times if we use the example of 10. And then result equals wait, what was it again? A x, so number XOR, why can't I type in the correct place today? Number XOR n, and we return that result and it should be fine, but it's not. What have we done wrong now? Your function fails on that, it returns that when it should return that. So okay, that's confusing me. So we have it's shifted. Is it shifted more than it's supposed to be? No, it's doing it less times, so that needs to be in another place. It's shifting too many times. Okay, I'm confused now. Off pun superintended, it threw your code looks so oh wow. A negative shift count error. Click the hint if you need help. Okay, let's actually do that. Use the that operator to move your mask into place and that operator to flip your desired bit. So let's look at this. So we have number as our number, then we make a mask which is 0b left shift operator -1, and we result is stored under that, and we need to print it as that. This is actually confusing me now. So we're shifting it in -1 times. Okay, I'll be right back. I just need to think this through, sorry. So what the problem was that I was doing the XOR of n instead of mask. That's where I went wrong. So it needs to be number XOR mask, not number XOR n. Okay, so that was actually quite a stupid mistake, but it happens. And that took me quite a long time actually, or longer than I would have liked it to. But it doesn't really matter. So if you like this video, then please click the like button, the share and subscribe. If you have any questions, ask in the comments down below. If you didn't like the video, then dislike the video and tell me why. So until next time, thanks for watching and goodbye.